everyone, and welcome back to the third presentation of the parallel session of digitalization. The topic of this round will be digital transformation of tunnel renovations, and we'll get a case presentation of the renovation of Koningstunnel in Den Haag. The presenter will be Jeroen Groenewegen from Infranea and Seuren from Siemens Mobility. And Stijn, please go ahead. The floor is yours.
Yes, thank you, Helen. Well, welcome everyone to our parallel session on the digital transformation of tunnel renovations. We will show you how we used digital transformation on the Koningstunnel in The Hague. But first, let me introduce myself and my co-presenter, Jeroen. I'm Stijn Seuren, and I work with Siemens Mobility. I've worked on the Koningstunnel project as a command and control engineer. And Jeroen Groenewegen worked with Infranea, and he worked on the Koningstunnel project as a BIM specialist. And over this session, we will tell you about the Koningstunnel project using the following 4 points. First, I will briefly introduce you to the Koningstunnel project and why it was challenging. Then Jeroen will explain how BIM was used during the project. In the third point, I will then explain what digital twin is and how it was used. And finally, we will conclude with the main takeaways of the project. So let's start with the project. The Koningstunnel is a 750-meter tunnel in the heart of The Hague, and it's located underneath the central railway station. It was therefore very important that to reduce the commissioning period as much as possible. The Koningstunnel project consisted of a complete tunnel reservation, including all the subsystems in the tunnel. The project was contracted by Siemens and Heijmans, and Infranea was involved on the digitalization aspect of the project. And for the digitalization, a building information model, or BIM, was used throughout the project. And it was used during the design, the engineering, and the commissioning phase. And it also served as the basis for our digital twin, which will be discussed in a moment. In the end of the project, it was delivered 5 weeks early, which was primarily realized thanks to the digital transformation. And we will explain this by showing you 7 ways how this transformation helped us during this project. After you, Jeroen.
Yes, thank you, Stijn. So we'd like to share 2 BIM methods that we've used on this tunnel renovation project with you that we think were very successful. And BIM and building information modeling in general is becoming more and more common knowledge within our sector. And it's used on many projects. So therefore, we think it's more interesting for you guys to highlight 2 approaches that we think work very well. And our advice would be to use them on any tunnel renovation project. So the first method is parametric modeling. Now, there was another session on that. I think it was the first session. And parametric modeling can be defined as a modeling process with the ability to change the shape of a model or geometry by basically changing its parameters. So by changing dimensions or measures, you can change the shape of the geometry. And in this case project, we've used Revit, Autodesk Revit for that in combination with Dynamo and Excel. And Dynamo is a tool that allows you to do visual coding. So you can build a script, and by running that script, you can change the parameters of a model. So these tools were used on this case project to apply parametric modeling. And we will take you to the process by illustrating it on a slide. So we try to explain how we've applied the parametric modeling approach in this project. And we'll explain a simplified example that illustrates the method that we've used for many of the TTI, the tunnel technical installation systems in the tunnel. Because most of the tunnel renovation projects that we encounter have some sort of replacement of TTIs in them. So a tunnel has an alignment most of the time. So this alignment is the line that's been used to design this tunnel, the center line. And in this slide, it's represented by the red line. And this alignment, it can be used in combination with parameters, and we've called them the mileage values, to apply parametric modeling. So each installation in the tunnel gets a mileage value that determines the location of the installation throughout the tunnel. And by updating this mileage value, by running the Dynamo script in combination with Excel, we can then change the location of the installation in the tunnel. So that's in a nutshell how we've applied parametric modeling. And this method was used in some way or another for all of the DTI systems in the tunnel, or most of the DTI systems in the tunnel. And it allowed us to update the design very quickly when changes occurred. So by running the script again, we were able to change the parameters and change the location of all the DTIs throughout the tunnel. So that in turn allowed us to process design changes faster. So this method, by using this method, we've created a model that represented the new design of the refurbished tunnel, which brings us to the next approach that we've used, and that was that we try to really bring BIM on site. So we try to use all the information and the model that we created during the design phase, and we try to bring it basically on site and use it during the construction phase. And in doing so, we had also two goals in mind. We tried to reduce drawings and improve the integration of information flows. And again, we would like to highlight one of the aspects of bringing BIM on site, which we call model-based surveying. And model-based surveying was used to use the models that we've created and determine the location, the mounting spots for all our installations on site. So in this slide, you see a lightning fixture and you see vertical lines, and these vertical lines represent the mounting points for this specific object. So this object has 4 mounting points, and we've created 2 survey lines that were used, exported from our model and imported into our total station and used to do the surveying on site. Now, for those of you that are not familiar with a total station is a piece of hardware that can be used in combination with a coordinate system to determine the location in the physical world. So by using 2 points for which the coordinates are known, it can know its location in the physical object, in this case, the tunnel. So we load our survey lines into this device, and then the operator, which this little clip will show you, the operator selects the lines he wants to survey, and then the device projects the location of the mounting spot for this object. He projects it on the surface of the roof of the tunnel, and in this case it was a CCTV camera. So by using this method, you end up with all these marks throughout the tunnel that represent the mounting locations for the different installations. And by using this approach, we were able to reduce the drawings on this project. And in turn, this led to less errors, rework, and overall faster construction. Back to you, Stijn.
Okay, thank you, Jeroen. I will now explain how the digital twin helped us during this project. But first, let me show you a short video on the digital twin itself.
Experience it at full scale, even if it doesn't exist yet. Siemens Mobility's digital twin gives designers, engineers, and decision makers that power. Digital twin. Realism improves reality.
So the video already gave a sneak peek of the digital twin, but what exactly is a digital twin? Now, for us, a digital twin is a digital 3D model that has dynamic objects and integrates fully with command and control software. So a digital twin is more than just a static 3D model. since it can behave like a real infrastructure object. As mentioned before, the digital twin uses a BIM model as a basis. And this model is then imported into a gaming engine, which will then serve as the basis for a digital twin. Can you click, Jeroen? Yes. The next step is to add dynamic objects to the digital twin. And these objects, such as traffic lights, cameras, and traffic, have identical behavior to the real traffic lights and real cameras. And the cameras that are placed throughout the digital twin can be used to generate video streams. And these video streams can in turn be shown on a video wall, similar to a real operating station. And finally, we can connect our command and control software to the digital twin. And this software is the same software that will be used to control the real tunnel. So with all these components combined, we have a digital twin that looks and behaves the same as the real tunnel, which gives us the opportunity to do several nice things. Yes. Okay. And I know the next slide, indeed. Yeah. So I'll show you several nice things we did with the digital twin. And the first is the camera placement in a tunnel. The customer had a requirement that there could not be any dead spots in the tunnel. So by using the digital twin, we came up with a camera layout that could fulfill this requirement. And we could also validate this requirement in the digital twin itself. The second use case was the operator training. Click. Since the digital twin closely imitates the real tunnel, we could train tunnel operators on our digital twin while the real tunnel was still in the commissioning phase. The third way we used the digital twin was to verify the line of sight for the truck drivers. Because with all the newly installed systems in the tunnel, we had to verify that the view of the truck drivers would not be obstructed by the new systems, such as the ventilators you see in the picture. And this line of sight was also verified using the digital twin. And then the fourth point is that the digital twin also allowed us to move through the tunnel in virtual reality. And during meetings with our client, we gave them a virtual tour in a tunnel so we could easily discuss the proposed placement of the different systems in the tunnel. And last but not least, we ran several scenarios in a digital twin, such as crashes or ghost riders. And this allowed us to extensively test our command and control software. And it helped us determine if the command and control software would react correctly to these different scenarios. So what are our main takeaways from the Koningstunnel project? Well, first to you, Jeroen.
So we've highlighted two of our BIM processes and methods. And the first one is use parametric design because it allows you to process design changes faster. And in turn, this can also allow you to maybe present multiple options of the design to your client. And the second one was to really try to use your building information model and all the information that you've created during the design phase, use it also during the construction phase by bringing BIM on site. And we've talked a bit about model-based surveying, which allowed us to reduce drawings and improve the information flow, which then in turn led to less human error on this project and less rework.
Yes. And for the digital twin, the four takeaways are the communication. The digital twin allowed us to easily communicate with the client through the VR option. Then it also allowed us to do extensive testing for the command and control software, but also to validate things like the camera layout and the line of sight for the truck drivers. We use the digital twin for educating the tunnel operators, and we use it to simulate different scenarios in the digital twin. And thanks to all these points, we were able to open the tunnel 5 weeks earlier than planned. And we'd like to close off with a nice quote we got from our customer. And he said, Siemens made a digital copy of the Koningstunnel in Zoetermeer. Everything that had to be done could be tested in this copy. And thanks to this, the renovation was completed much faster than we expected. And we see this as a nice conclusion of a very successful project. Thank you.
Thank you.
Thank you, Jeroen and Stijn. I'll put forward one question to you both, and then you have to decide which one of you who is going to answer. The question is the digital twin only used for the renovation, or is it also of use in the exploitation phase afterward? And also, who is the owner of the digital twin? Infranea, Siemens, or the assets owner?
Currently, the digital twin is owned by Siemens, and we still have the copy running in our office, and it can still be used to train operators if a new operator would operate the tunnel in the future. But for now, the digital twin isn't actively used.
And I think I'll go for one more question because we still have some time left. Did you also incorporate the cables and the cable support systems in the model? I think this one is for you, Jeroen.
We did incorporate cable support systems like cable trays and piping, but not the actual individual cables. So we've only added the cable trays, the cabinets, piping, and for this project, I think it was sufficient. And that's our approach on most projects, to not go into any further details within the model, because we think there's no added value or benefit in modeling all the individual cables. I don't know if that gives an answer, but I think it's a question that arises on a lot of projects.
Yeah. Thank you. And thank you once more, both of you, for a really good and interesting presentation. We have to move on for the final time of this parallel seminar into round 4. The round 4 will start in just 2 minutes. So let's move to the last digital meeting room. I see you there.
Okay.
Okay, thank you.